This is a circuit diagram, a schematic. And this is the same circuit built for real on a breadboard. In this video, I'll show you exactly how to convert a circuit diagram to a breadboard, how to read the schematic and turn every line and every part into holes and jumper wires you can actually build with no soldering and no guesswork. First, I'll show you how a breadboard works on the inside, because once that clicks, the conversion is easy, and then we'll take a real circuit and convert it part by part from schematic to board. Let's go. Before we convert anything, you have to know how a breadboard is wired on the inside, because the holes are not all separate. They're connected in a very specific pattern, and that pattern is the whole secret. Start with the two long strips running down each side, usually marked with a red line and a blue line, a plus and a minus. These are the power rails. Every hole along the red rail is joined together, electrically, the full length of the board. Same for the blue rail. Every hole in it is one single connection. So when you feed power into one end, it's available all the way down. Red is your positive rail, blue is your negative rail. Now the main area in the middle. It's split into columns, and it's numbered column 1, 2, 3 all the way across. Each column has 5 holes on the top and 5 holes on the bottom. Those 5 holes in a half column are all connected together. Electrically, they are one single point. Push 2 component legs into the same 5-hole group, and they're joined, no wire needed. But here's the part everyone misses. The top 5 holes and the bottom 5 holes are separated by the gap running down the center. The top half of a column and the bottom half of the same column are not connected. That center gap is there on purpose. It's exactly the right width for a chip, an integrated circuit, to straddle it, so each row of legs lands in its own separate column on its own side of the gap. Rails down the sides, 5-hole columns in the middle, a gap down the center. Lock that in, and everything else follows. Quick heads up, everything in this video is drawn in CircuitDiagramMaker, a free website that runs right in your browser. No download, no sign up. You can open a schematic, plan your breadboard layout, and even simulate the circuit before you build it, so you catch mistakes on screen instead of on the bench. The link is below. So here's the method, and it's simpler than you'd expect. A schematic is really just a set of connections. Every line you draw between 2 parts is a wire, and everything joined by that wire is one electrical node, one net. You convert the circuit net by net. The rule is this. Every net in the schematic becomes one connected group on the breadboard. If 2 component legs are joined by a line on the schematic, they must end up electrically together, in the same 5-hole column or in 2 columns linked by a jumper wire. And if they're not joined on the schematic, they must stay in separate columns. So you do not copy the shape of the drawing. The layout on the board can look completely different. You copy its connections. Walk the schematic one node at a time, and for each node, ask a single question. Which part legs share this node? Put those legs into one column. If they're too far apart to share a column, run a jumper wire between the 2 columns, and now they share the net. That's the entire game. Nets in the schematic become connected columns on the board. Now let's map the actual parts. Here's a real schematic, open in the free editor, so you can see what we're reading. The battery, or power supply, goes to the rails. Positive terminal to the red plus rail, negative terminal to the blue minus rail. Do this first, and now power is sitting ready all the way down both sides of the board. A resistor spans 2 columns. Its 2 ends are different nets, so you place it across 2 separate columns, often straight across the center gap, 1 leg in each. Never both legs in the same column, because that shorts the resistor out and it does nothing. An LED has polarity. It only works one way round. The longer leg is the anode, the positive side. The shorter leg, next to the flat edge of the case, is the cathode, the negative side. On the schematic, the triangle points from anode to cathode in the direction the current flows. Put each leg in its own column and get the direction right, because if you fit it backwards, the LED simply stays dark. And jumper wires finish the job. A jumper is just a short link that carries a net from one column to another or down to a power rail, wherever the parts can't reach each other directly. Every net that needs connecting and can't share a column gets a jumper. Let's convert one complete circuit, start to finish, so you can see the whole flow. The schematic is a simple loop, a battery, a resistor, an LED, and a wire back to the battery. Start with power. Battery positive to the red rail, battery negative to the blue rail. Now walk the nets. From the positive rail, we need to reach the resistor, so drop a jumper from the red rail up into an empty column. Call it column 5. The resistor's first leg goes into column 5, sharing that net. Its second leg reaches across the gap into column 10. The current has now crossed to a new net in column 10. Next, the LED. Its anode, the long leg, goes into column 10, so it shares the net with the resistor. Its cathode, the short leg, goes into column 15. Anode toward the resistor, cathode toward ground, polarity handled. One net left. From column 15, run a jumper straight down to the blue minus rail, and that closes the loop back to the battery negative. Trace it, plus rail, jumper, resistor, LED, jumper, minus rail. Every line on the schematic now exists as a connection on the board. Power it up and the LED lights. That's a circuit diagram converted to a breadboard. Before you build, here are the mistakes that catch almost everyone. 1. Confusing the rails. The long side rails are power only, plus and minus. Don't run a signal along a power rail, and always double-check you didn't push a component leg into a rail when you meant a column. 2. A floating net. Every net in the schematic has to exist on the board. Miss a single jumper, and part of your circuit is left disconnected, floating, and the whole thing just won't work. 3. A chip that doesn't straddle the gap. If you press an integrated circuit flat into one half of the board, every leg on that side shorts to its neighbors. The chip must sit over the center gap, one row of legs on each side. For a resistor with both legs in one column. Same column means both legs are the same net, so you've shorted the resistor. Each leg needs its own column. And 5. The LED in backwards. If it won't light, flip it. Long leg to the positive side, short leg to the negative side. One last tip before you build. Know your symbols. A battery, a resistor, an LED, a switch. If you can read the schematic symbols at a glance, converting to a breadboard becomes effortless because you instantly know what each part is and which way it goes. Here's a free symbol chart you can revise from. Every common symbol on a single page. Screenshot it and keep it next to you while you build. So that's how you convert a circuit diagram to a breadboard. Remember how the board is wired. The two long side rails are power, plus and minus, the full length. Each half column of 5 holes is one connected point, and the center gap splits every column in 2, so chips can straddle it. Then convert net by net. Every connection in the schematic becomes one connected group on the board, either the same column or a jumper between columns. Battery to the rails, resistors across the gap, LEDs the right way round, and jumper wires to finish every net. Open CircuitDiagramMaker, load a schematic, and plan the whole build on screen before you touch a single wire. It's free, it runs in your browser, and the link is right below. Subscribe if this made breadboards finally make sense, and happy building.